Okay, so the next question asks, what are the 4 steps for constructing a stem and leaf plot? I changed it to 5. First of all, we found the max and the min, so we knew what to make the beginning and end of our stem and leaf, our stems especially. And then we had to decide what's our stem and what's our leaf. In this case, it was the ones place versus the tenths place. Then we wrote our stems in increasing order in a column. Then we wrote the leaves out there corresponding to each stem. Then we rearranged the leaves in order, ascending order, numerical order. And then lastly, we titled our plot and included a legend. All right, so what are the advantages of a stem and leaf plot over a frequency distribution or a histogram? You can get the raw data back. Raw data can be discerned, can be retrieved, however you want to say that. The idea being I can look at this stem and leaf plot and I know that 17.2 was one of the data points. I also know that 15.3 and that 14.2 was one of the data points. Not always the case in the other strategies. The other thing I like about it is it's pretty fast. Rather than having to draw those bars and figure out how many you have in each bar, in order to draw it, you just throw those stems on there, and even if you don't arrange them in increasing order like you're supposed to in an official stem and leaf plot, you can still kind of get the distribution of your data, where the peak is and what's going on, even if you don't put them in ascending order. So I love that. It makes a graph, I think, is fabulous. And then under what conditions do stem and leaf plots lose their usefulness? Well, when you have a lot of data, large sets of data, you could be here all day trying to make a stem and leaf. Or a large range of values would be the other situation, large range of values. And just by that we mean that, you know, if my first number is 1 and then my second number doesn't come in until 500, or if maybe the first, few numbers are 1 through 10 and then I've got this other number way down here, 500, whew, man, you wouldn't want to put all those stems 10 to 500. Again, you'd be here all day. And then the last question about stem and leaf plots says, when constructing a stem and leaf plot, under what conditions is it advisable to split stems? And you're saying, what is a split stem, Ms. Benton? Well, I have an example over here where I've split my stems, and the idea is if you have a lot of the same numbers, let's say like you had a really tall peak on your 2s, you might want to split those up. And so what we do is we split stems. We make 2 1 categories, 2 2s, and 2 3s, so on and so forth, 2 4s. And so 1 2, you'd have 0 through 5 on the first stem, and then 6 through 9 on the second stem. So that's how that works. So 2, and then I had a 1 1 and a 1 4. That's these 3, and then I didn't have anything here, but then I had a 2 and a 3, a 5 and a 4, but then I can put 8 and 9 on this other stem. And then a 3 and a 4 here, and then there's nothing there. Anyway, so when would you want to use split stems? And you generally want to do this when the data is bunched up on around one particular stem, is bunched around 1 or 2 stems. Or just in general when it's bunched, to be honest. Around, we'll say, a few stems. How about that? There you go.